Hey guys, this is Carrie, and this is the answer key to homework number 4. Alright, so we're going to be factoring each of the following expressions. We have 2 methods for factoring, so I'm going to write them here. 1, greatest common factor. 2, sum and product. Alright, so for the first one, since we only have 2 terms, this is going to be a GCF factoring problem. So we need to figure out what they have in common. 12 and 8 are both divisible by 4. X to the 7th and x to the 5th share x to the 5th in common. So that will leave us with 4 times 3 is 12. X to the 5th, factored out, leaves us with x squared. 4 times negative 2 is negative 8. And we factored out all 5 of these x's as part of our GCF. For part B, let's see. These have nothing in common. This must be a sum and product factoring problem. That's my end symbol. So we have to set it up with our 2 parentheses. X times x gives us x squared. We have plus 5x minus 24, so we're looking for 2 numbers that add to 5 and multiply to negative 24. So positive 8 and negative 3. For the next problem, hopefully I've corrected this in your homework, but on mine I notice I have a typo. This should be 2x squared. So thinking about factoring this one, because of the 2 here, this is not sum and product. So hopefully we're able to use GCF. So 2, 4, and 30 are all divisible by 2, so we'll factor out a 2. That leaves us with x squared minus 2x minus 15. Now, you might think you're done with this problem, but if you look inside parentheses, this group right here looks a lot like a sum and product problem. So we'll keep the 2 from our GCF, and let's factor that pink part into a sum and product. So the first step was GCF, and now we're using sum and product for this step. So the 2 is this 2. X times x is x squared. 2 numbers that multiply to negative 15 are negative 5 and positive 3. Those also add to negative 2. As well as multiply to negative 15. So this is our final answer. Make sure you don't forget the 2. The 2 is still part of the problem. So the 2 is from the GCF. For the next problem, it's asking us to completely factor this expression. This expression looks a lot like sum and product. The only difference is, instead of having x squared, we have x to the 4th. So let's set the puzzle up the way that we might normally. In order to get x to the 4th, instead of having x times x, we'll need x squared times x squared. Let's see. Now we're looking for 2 numbers that add to negative 7 and multiply to 6. Negative 6 times negative 1 is positive 6. And negative 6 plus negative 1 is negative 7. So these are our numbers. And if you distribute it out, this is like kind of an extra check you can do. They'll get x to the 4th. Notice that this term and this term both give you x squareds, which combine to make negative 7x squared, as the original had. And then negative times negative here gives you positive 6. So this satisfies the check and also is correct. Next we move on to this whole idea of solving using factoring. So if we're multiplying 4 numbers, we've got a blue number, a red number, a pink number, and a green number. If you're multiplying all of these numbers to get 0, then what you'll know is that to multiply things and get 0, one of those things has to be 0. So either this blue thing is 0, or this red thing, t minus 5. I know it looks like 2 numbers, but I'm calling it a single number because t, whatever number that is, minus 5 would result in 1 number. T minus 5 is 0, or t minus 1 is 0, or, in green, t plus 3 is 0. And if one of these things is 0, then 0 times anything times anything times anything would be 0. So if t minus 9 is 0, that means that t has to be 9. If t minus 5 is 0, that means t has to be 5. If t minus 1 is 0, that means t has to be 1. And if t plus 3 is 0, that means that t has to be negative 3. So So if t is any of these values, we'll have 0 in one of these spots. So having 0 in one of these spots will make the whole product 0. Solve the following equation, x squared plus 6x plus 8 equals 0. All right, so I want to turn this problem into a problem that looks somewhat like this. So luckily we know how to factor the left-hand side. X times x is x squared. We're looking for two numbers that add to 6 and multiply to 8. Those numbers are 4 and 2. Now if this times this is 0, then either this is 0 or this is 0. To make this 0, x has to be -4. To make this 0, x has to be -2. And you might say, well, we got two solutions. That's crazy. But we expect to get two solutions because the highest power here is 2. So we expected and got two solutions, which is a really nice check of our work. Next up, I'm going to leave this problem to you. I think that, well, maybe let's see. Yeah, I'll leave this one to you. For problem 6, I'm going to, let's solve this one. Okay. So we have x squared minus 11x minus 16 equals -4x minus 8. When you solve a problem like this, the goal is that when you have it equal to 0, you have that nice property where one of the things has to be 0. So our first step in solving this problem is going to be to get this equation equal to 0. So I might add 4x on both sides of the equal sign. I'll add 8 on both sides of the equal sign. And that leaves me with x squared minus 7x minus 8 equals 0. Now that we have the equation, or actually I'll write that step, make it equal to 0. Now that we have the equation equal to 0, we need to factor it, right? So we have x squared, so that will be x times x to give us x squared. And then we'll do two numbers that add to -7 and multiply to -8 would be -8 and +1. So now in this pink step, we turn this problem into a multiplication problem where two factors being multiplied equals 0. That means either this factor is 0 or this factor is 0. That means x equals 8 or x equals -1. For problem number 7, let's see, we've got f of x is this function and g of x is that function. For what values of x does f of x minus g of x equal 11? So basically, similar to the problems we did in unit 1 or lesson 1 from this unit, we're going to plug in the rule for the function where we see it. So we'll get x squared minus 4x minus 6 minus, and now we're subtracting all of g of x, so we're going to subtract in parentheses x minus 3. This has to equal 11. So I hope that you remember to include your parentheses when you wrote that, because that will remind you to distribute your minus sign to both terms. That gives us x squared minus 4x minus 6 minus x. Negative times negative is plus 3 equals 11. Now we have x squared combining like terms, minus 5x minus 3 from these two equals 11. And similar to the last problem, we want to make this equal to 0. So we subtract 11 on both sides. That gives us x squared minus 5x minus 14 equals 0. Now this problem continues, but I'm going to leave the continuation for you, as I think we've done the new part, and the rest is more sum and product. All right, solve the following equation for all values of x. This problem looks really crazy because we have the square root. Because we already have the square root group isolated, our first step is going to be to peel that square root off of the expression. So we square both sides to cancel out the square root. That leaves us with 5 minus x equals x minus 3 times itself, because that's what squaring means. 5 minus x equals x squared minus 3x minus 3x plus 9. Combining like terms gives us 5 minus x equals x squared minus 6x plus 9. Now we need to set it equal to 0. So we'll subtract 5 from both sides, we'll add x to both sides, and we get x squared minus 5x plus 4 equals, these two cancel out, so it equals 0. Now this equation is a major breakthrough because this is a sum and product problem that we can solve. So let's take the start equation, rewrite it up here. X squared minus 5x plus 4 equals 0. Now factoring that gives us x times x equals x squared minus 4 minus 1, because negative 4 plus negative 1 is negative 5. Negative 4 times negative 1 is positive 4. Now, because we need two numbers that multiply to 0, either this is 0 or this is 0. That means that x equals 4 or x equals 1. I hope you don't think we're done with the problem, even though I put the box, because that's a mistake. This problem has a dangerous square root in the original problem, which means we need to check our answers. So we check them separately. So let's check x equals 4. So we have square root of 5 minus 4 equals 4 minus 3. So we're checking this one right now. 5 minus 4 is 1. 4 minus 3 is 1. The square root of 1 is 1. These are equal. X equals 4 checks out. However, x equals 1 could be an extraneous solution. So we'll check x equals 1. So we get 5 minus 1 equals 1 minus 3. 5 minus 1 is 4. The square root of 1 minus 3 is negative 2. Square root of 4 is 2, and 2 is not the same as negative 2. So x equals 1 is false. This is an extraneous solution. So we only have the single solution, x equals 4, to this problem. I hope you remember to check your work, because that was tricky. Problem number 9 is a pretty crazy challenge question. So this was an extra credit one. So let's see. This looks a lot like a sum and product problem. So I'm looking for two factors, and I'm looking for here in the first spot something that times itself gives me x. So I want something times itself that gives me x. Something times itself means something squared. So I want something squared that gives me x. So this is actually an algebra problem, right? If I want something squared that gives me x, then to figure out what something is, I should just get rid of the square. So we can square root both sides. That shows us that something is equal to square root of x. So it must be that we have square root of x here and square root of x here. Let's see, square root of x times square root of x. Well, that's the same thing as this thing times itself, square root of x squared. But square roots and squares cancel. So square root of x times square root of x is x. It works. Now, the rest of this looks like a sum and product problem where we have the coefficient 8 that we need to add to and the constant 12 that we need to multiply to. So what are two numbers that add to 8 and multiply to 12? That's our 6 and 2. So 6 times 2 is 12. 6 plus 2 is 8. The last thing is, because this one looks kind of crazy, we should probably distribute it out to check it. Square root of x times square root of x. You see by the work over here that that is just x. Square root of x times 2. Well, that's 2 outside of the square root, x within the square root. 6 times the square root of x is 6 square root of x. 6 times 2 is 12. These are like terms, so we get x plus 8 square root of x plus 12, which is the same thing as our original equation. So this must truly have been